6, graphs of rational functions. Alright, so we're going to find the domain of the function and use limits to describe the behavior of f at the values of x not in its domain. So number 2, f of x equals negative 3 over x minus 1. So to find the domain of something like this, I need to set the denominator equal to 0 and solve, because obviously that's what's going to cause the problem. Everything else will be part of the domain. So x minus 1 equals 0. So at x equals 1, there's a problem. So my domain is going to be from negative infinity to 1, not including union 1 to infinity. Now, because there is a 0 at 1, what also do we know about this? What is there? What happens when the denominator is equal to 0? What do I have? So what is there because it's undefined? Huh? Sort of. What's the name for this one? Something we can't cross.
Asymptote.
What kind?
Vertical or vertical?
There's a vertical asymptote there. So we don't have to do that for this problem, but in 2 problems we will be looking at asymptotes, so it's good to remember. So we can look at the limits, okay, from each side. So what it wants us to do with these is to consider the limit of the function to describe the behavior of it. Thank you. So I'm going to look at the limit as x approaches 1. And when I put a little negative sign on the exponent, that means from the left of f of x. And so 1 from the left is going to be a number like 0.99999 and so on and so forth. Okay? So if I put a number like that here, and I plug in that number, what happens to this? Yeah, because it's going to be a negative over a negative, so it's going to be positive. And if I have a number over a really, really tiny number, what happens? What happens if I divide by a really tiny number?
That's like a decimal?
Alright, so if I plug in this number here for x, so negative 3 over 0.999 minus 1. What kind of number is this? A really big number. So what really, really big number do you think I'm looking at? Positive infinity.
Oh. People don't know.
Oops. Notice the more 9s that I have, which this is supposed to be as x is getting really close to 1, but coming from the left side, the number keeps getting bigger. Okay, so that's what we're looking for. Now I need to look at it from the other side. So the limit as x approaches 1 from the right, so if I put a little plus sign up here, that means from the right of f of x. That means I'm looking at a number like 1.00000001. Okay, what's going to happen if I do that? negative infinity. Okay? So if you need to see it, I keep hitting the wrong button. It's a really big negative number, essentially. Okay, so that's what we're looking for on those as far as what's happening. So, number 4, f of x equals 2 over x squared minus 1. So I need to find the domain of this. How am I going to do that? Yep. So x squared minus 1 equals 0. X squared equals 1. So then what do I get?
Plus 1 and then.
Yep, so x equals plus or minus 1. So that means that my domain is going to have basically an additional part to it. I'm going to have negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Okay, so it's all numbers except for negative 1 and 1, so we're not including those because that would cause a problem. So my limits, the limit as x approaches negative 1 from the left of f of x. So notice a number like that is going to be something more like, because it's a negative number, negative 1.00001 or something like that, right? Because that's on the left side of negative 1. So when I plug that in, and eventually you'll get to where you don't actually need to like see it typed in, but oh, there we go. So 2 over, I would put it in parentheses, negative 1.0001 squared minus 1. What do we think is going to happen?
It's gonna get bigger.
Yep. So it's going positive infinity. Then if I have the limit as x approaches negative 1 from the right, what kind of number would that be? Yep. So really big negative number, so this one's going to negative infinity.
Is this how you want us to write it? Like,
I don't necessarily need to see this number. I'm just doing this for reference point for you, but. And I mean, once you get more used to it, like you won't have to be typing anything in your calculator. You'll just be able to kind of see what's happening. Because you'll be able to be like, okay, well, that number's being squared, so regardless, that's positive, and then. But. Now, I should also do it for 1, but we're going to be doing more with limits, so I'm just going to leave it at that. But that's basically just confirming that it's an asymptote. Because at an asymptote, the whole function's either going to infinity or negative infinity. So that's really the purpose of that. Specifically at a vertical asymptote, I should say. All right, number 8. Okay, we're doing this a little different than the instructions say. We're going to be finding the horizontal and vertical asymptotes. Let me and then we're going to confirm with limits. So there's some other stuff that they tell you to do we're not doing on these ones. So number 8, f of x equals 3x minus 2 over x minus 1. So I need to find my vertical and horizontal asymptote. So where is my vertical asymptote? At 1. So it'll be x equals 1. Remember, asymptotes are written as equations of lines. Set the denominator equal to 0 and solve. Horizontal asymptote would be where? Yep, y equals 3. It's your Bobo, Botno, Bosco. These are both the same, so use the coefficient, which is 3. Now we're confirming with limits. So we've just done these last two problems. We've confirmed the vertical asymptote without you really knowing that's what we were doing with limits. And then we'll also confirm the horizontal one, but it is a different way that we do that. So for vertical, I have the limit as x approaches 1 from the left of f of x. So if I put in 0.999999, what's happening? So basically, is it going to positive infinity or negative infinity? Going positive or negative? So I've got 3 times 0.9999 minus 2 over 0.9999 minus 1, negative number. So negative infinity. The limit as x approaches 1 from the right of f of x would be something like 1.00001. So where's this one going? Positive infinity. Because that's going to make this down here positive, and that number would be positive. So now horizontals are a little different. For these ones, we're looking at the limit as x approaches negative infinity, and that should be equal to the limit as x approaches infinity of the function. And that's what we're trying to find. Okay, so if I were to plug in a really, really big number, or a really, really small number, if you want to say that, negative infinity is technically really small, all I need to look at is these first terms. At a number like infinity, adding or subtracting things like 2 or 1 or even 25 are not going to change anything. So all I care about is the highest power term when it comes to that stuff. So I like to put in like 500, okay? But if I ignore that, I have 3x over x. What's happening? They're divided by the same number. Because I have x over x, I can reduce, so that means that this is going to 3. So it doesn't matter if I plug in a positive 500 or a negative 500, it's going to cancel, and I'm going to be left with 3. And that is just confirming that my vertical asymptotes and my horizontal asymptotes are really where I think they are, essentially. Let's see, 10. F of x equals 4 minus 3x over x minus 5. So where is my vertical asymptote? X equals 5. What about horizontal? What?
3 or
Negative 3. Y equals negative 3. So they have the stuff written out of order, so got to make sure you pay attention to that, which obviously you did, but just make sure you watch that stuff. So I'm going to look at the limits for my vertical asymptote. So the limit as x approaches 5 from the left, and I'm also going to be looking at the limit as x approaches 5 from the right. So if I put something like 4.99999 in there, what's going to happen? It's going to end up with a negative over a negative, right? Negative 3 times negative something is going to be a positive. Nope. Oh, wait, it's not a negative number. Sorry. 4.999. A positive number. Negative number times a positive number is negative over a negative number. So that is positive. A positive infinity. Five from the right, so that would be something like 5.0001. Where's that one going? Negative infinity. All right, and then I need to do the limit for horizontal, so that's going to be the limit as x approaches negative infinity should be equal to the limit as x approaches infinity. So what happens if I put a really, really big number in for x? So all I'm looking at is the negative 3x over x part. The other numbers are irrelevant. They're not going to change anything. So what happens if I plug in a really big number? It's going to be negative 3. Because everything else is going to reduce. So this number should match this if you've done it right. If for some reason you're confident about this and not this, then I would go back and look and make sure you've correctly found your horizontal asymptotes. Okay, 20 is a different like section, but you're doing the exact same thing we just did in those ones. So number 20, f of x equals 3x squared over x squared plus 1. So what's my vertical asymptote? Huh? So asymptotes have to be real numbers. So what happens if I set this equal to 0, x squared plus 1 equals 0, I get x squared equals negative 1. Take the square root of that, I get x equals plus or minus I. Okay? I can't have an asymptote at a non-real number, so There are none. There are no problem numbers that I can plug in here. Now, what about the horizontal asymptote?
No, there's none.
3. Both the same. Use the coefficient, which is 3, so y equals 3. So now, there's no vertical asymptote, so there's no limit that I need to confirm on that one. I just need to confirm the limit for 3. So the limit as x approaches negative infinity is equal to the limit as x approaches infinity is equal to. So if I plug in a really, really big number for x, what happens? It goes where? What'd you say?
Positive.
Yep. Specifically 3. All right, for 23 through 30, it's just modifying the instructions a little bit. You're just finding the asymptotes and the intercepts. Okay, so to find asymptotes, to find vertical asymptotes, we set the denominator equal to 0. To find intercepts, the x-intercept, we set the numerator equal to 0. The y-intercept's a little different, but number 24, g of x equals x plus 2 over x squared plus 2x minus 3. So I want to find my horizontal and vertical asymptotes. How would I go about finding a vertical asymptote?
Set the denominator to 0.
So I'm going to have x squared plus 2x minus 3 equals 0. Now what do I have to do? What does it factor into?
X squared plus 3x minus 1.
Do you just take out an x?
So
It is x.
x plus 3x minus 1. So I would have one at x equals negative 3 and one at x equals 1. So that's my vertical asymptote. Horizontal asymptote, this one's a little different than the ones we've been having. Where would this one be? Don't remember Bobo, Botno, Bosco. Y equals 0. Bigger on bottom, y equals 0. Alright, so those are my two asymptotes. So now I need to find intercepts. So to find an x-intercept, we set y equal to 0. So that would just be taking this whole thing and setting it equal to 0. So I'm going to have x plus 2 over x squared plus 2x minus 3 equals 0. But if this is equal to 0, then when I multiply by the denominator on both sides, it completely goes away. So all I really care about is the numerator. So x plus 2 equals 0. So x equals negative 2. Now that means that my intercept, it's at a point. That means where it crosses the x-axis is at negative 2, 0. So this is the x-intercept here. Now, if I want to find the y-intercept, what do you think I need to do?
Set X equals 0.
Set x equal to 0. So that means I'm going to have y equals, everywhere there's an x, I'm putting a 0. So 0 plus 2 over 0 squared plus 2 times 0 minus 3. Now, I wouldn't normally probably even write these terms that end up being 0 or like 0 squared or 2 times 0. I'd probably just ignore that, but just for the sake of placeholder and you seeing it. So what does y equal to?
Negative 2 over 3.
Negative 2 over 3. So my intercept point, this is where it crosses the y-axis, would be at 0 and negative 2/3. So this is the y-intercept. Any questions about that? The only thing that's different about these is just setting x or y equal to 0, which is the same way you would have found intercepts when you had a linear equation. Just now there's more pieces to it. All right, problems are, and make sure you do them just like we just did, like with the modified instructions. 1, 7, 9, 19 and 23.